Okay, thank you, well done to inviting me here for today in order to proceed with our lesson of chemistry, particularly in the part which you call the volumetric analysis. But before proceeding, let me provide thanks to God who provided energy for me in order to exist here for the purpose of exhausting what I have to my learners. But welcome my learners from Uganda, welcome my learners from Tanzania, welcome my learners from Kenya, as well as welcome my learners around the world who follow my lessons. Particularly, not only but also thank you my learners for participating in a live or this lesson of chemistry. But for today we will much concentrate on the identification of the relative atomic mass of unknown element in an acid or alkali. But before proceeding, we are supposed to know the concept of volumetric analysis. Why we are required to know the concept of volumetric analysis? There is a reason behind. I will tell you later on. Volumetric analysis is the process of determining the accurate volume and the concentration of reactant species in a solution. And the solution here is given in decimeter cube or 1 liter. Not only, but also that concentration can be given in either mole per decimeter cube or capital letter M, or it can be given in terms of mass concentration, which mass concentration can be represented by gram per decimeter cube. To deal with the calculation in order to find out the unknown element or to find out the relative atomic mass of unknown element, we are supposed to know the concept of volumetric analysis due to the fact that to know unknown elements or know the relative atomic mass of a given element worked out by titration data, in which the titration data is the output of the process of volumetric analysis. So in order to find out in order to identify the relative atomic mass of an unknown element or to find out a known element, we are supposed to have the titration data. So on the other hand, you can say that volumetric analysis can be used to identify a known element or a known relative atomic mass. Up to here, let us see the example in which you can deal with it in order to identify the relative atomic mass of a known element in alkali or base. Mean that we are supposed to perform the titrations, then to get data of titration. That after getting the data of titration, you can find out the relative atomic mass of unknown elements. We have an example here. Have an example here in which this example here we are going to deal with it in order to find out the relative atomic mass of unknown element. But here we have a question here that 20 centimeter cube of solution in which that solution contains 7 gram per decimeter cube, in which 7 gram per decimeter cube, that is the mass concentration of that metal hydroxide. So 20 centimeter cube of solution contains 7 gram per decimeter cube of a metal hydroxide, in which this metal hydroxide we have unknown here, in which we are supposed to find out. Were exactly neutralized by 20 centimeter cube of 0.1 HCl molarity, meaning that 0.1 HCl. This is the concentration of this is the concentration of hydrochloric acid, but this is the volume of hydrochloric acid. If that we are required to calculate the molar mass of OH or unknown element or unknown compound. In order to find out the relative atomic mass of an unknown element, according to nature of this question, we are supposed to find out the relative atomic mass of one compound. Then we will substitute in order to find out the relative atomic mass of a given element. So up to here, let's see now here. We have molarity of acid is 0.1 M HCl, but also here we have a number of base, a number of acid we don't have, but volume of acid we have 25.00 centimeter cube, but also molarity of base here we don't have. But also volume of base we have 20 centimeter cube, 20.00 centimeter cube, but also number of base we don't have. where we can find out the number of base. In number of base, we are supposed to balance the chemical equation in order to see the mole ratio, in which from mole ratio we can calculate. So let us begin to see how it is. So let us begin to see how it is. So let us begin to see how it is. But here we have 7 grams per decimeter cube. This is the mass concentration of a known metal hydroxide. This is the concentration of that's the mass concentration of this is the mass concentration of given this is the mass concentration of metal hydroxide. So we are supposed to balance the chemical equation. So here we have XOH plus hydrochloric acids. We are supposed to get the X from XOH, but HCl plus H2O. Mean that this is a neutralization reaction here, a chemical reaction here undergone. After balance this chemical equation, when we find out here how to see it, the single X, single chlorine, here have 2 hydrogen, you have 2 hydrogen, 1 oxygen, 1 oxygen. So it will be balanced. So the number, the mole ratio, by considering the reactant sites, number of acid is equal to 1, number of base is equal to 1. So number of base, we are supposed to recall the mole ratio formula, in which recall molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. So here we need to find out the molarity base. So if we need to find out the molarity base, we are supposed to cross multiplication. So molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. Here we are supposed to cross multiplication. In cross multiplication here, we are making static molarity of base. So molarity of base, volume of base, number of acid is equal to molarity of acid, volume of acid, number of base. Notation here, it's finding out the molarity of base. So here molarity of base, volume of base, number of acid is equal to molarity of acid, volume of acid, number of base, divided by volume of base, number of acid, divided by volume of base, number of acid. So divide that, this will cancel. After that to be cancelled, after this to be cancelled, here we end up with this. So molarity of base is equal to molarity of acid, volume of acid, number of base over volume of base, number of acid. So we are going to using this formula to find out the molarity of base. So let us see how it is. So molarity of base is equal to molarity of acid, volume of acid, number of base over volume of base, number of acid. So here we have a molarity of acid here, which is equal to 0.1. So molarity of acid is equal to 0.1 times volume of acid, which is equal to 25, times number of base, which is equal to 1 over molarity over volume of base, in which volume of base is equal to 20, times number of acid, which is equal to 1. So this is equal to molarity of base. If this is equal to molarity of base, when found out here, you will wind up with molarity of base is equal to 0.125 mole per decimeter cube, or capital letter M, mole per decimeter cube. Question here need for us to find out the molarity of base. So after getting the molarity of base, we can find out molar mass of a given compound, in which that compound carry the metal hydroxides. So let us see how it is. So here we need to find out the recalling molarity is equal to concentration in gram per decimeter cube over molar mass. Our intention here is to find out the molar mass of base in order to find out the relative atomic mass of unknown element. So we proceed with the molarity. Molarity is equal to concentration in gram per decimeter cube over molar mass. I want you to find out the molar mass. So we are supposed to make subject. So molarity times molar mass. So molarity times molar mass is equal to concentration in gram per decimeter cube. So our intention to find out molar mass. So we are dividing by molarity. So this will cancel. After this to be cancelled, we will end up that molar mass is equal to concentration in gram per decimeter cube over molarity, in which this molarity is mole per decimeter cube. So up to here, let us proceed to see how it is. So molarity of base is equal to 0.125 m or mole per decimeter cube. So we call that. So molar mass is equal to concentration in gram per decimeter cube of molarity. So how to find it is that. So concentration which is equal to 7 gram per decimeter cube should be divided by molarity, which is equal to 0.125 mole per decimeter cube. When you find out here, we take this one, divide by this one, you will end up with 56.00 gram per mole. So the molar mass of this compound X or H is equal to 56.00 gram per mole. So let us find out the unknown molar mass of unknown element. So here we have X or H. So here we have X or H is equal to 56.00 gram per mole. So you have X plus hydrogen which have 16 molar mass plus hydrogen which have 1 molar mass plus, which is equal to 56.00 gram per mole. When you add here, we have X plus 17.00 gram per mole is equal to 56.00 gram per mole. So this we need to collect the right term. To collect the right term, we are supposed to write X plus 17 minus 17 is equal to 56.00 minus 17.00. Both this is a gram per mole. gram per mole. So X here will be is equal to this one, 56 minus 17 is equal to 39.00 gram per mole. So after knowing this is the relative atomic mass of unknown element. This is the relative atomic mass of unknown element. After knowing the relative atomic mass of unknown element, we are supposed to substitute this after substituting this the 17 as a gram per mole as the relative atomic mass of OH. Then substituting this molar mass which have been obtained from the molecular base, we are getting the 39.00 gram per mole. In which this, in order to define this, we are supposed to pass to have the concept of the periodic classifications. After knowing the concept of periodic classification here, when we look in the periodic table, in the group 1, we can find the element with the relative atomic mass of 39, in which is potassium. So the element, to identify the element X, so element X is equal to potassium, is equal to potassium, which is represented by a letter K. So element X is equal to potassium, and the relative atomic mass of a known element, which now is known, which is potassium, was the 39.00 gram per mole. And this potassium in the periodic table is found in the period 4, group number 1 in the periodic table. So in group, it is found in group 1 and period 4 in the periodic table. Up here, this is the way. This is the simple way on how to find out or to identify the unknown element in a given compounds, or also to find out but also to find out the relative atomic mass of unknown element in either acid or base by using the titration data. So up here, let me say thank you my learners from Ghana, thank you my learners from Tanzania, also thank you my learners from Kenya, as well as my learners around the world who follow me in my lessons. So up here, let me say thank you. Bye-bye. Enjoy chemistry. Okay, thank you, well done. Let us proceed with our lesson for today, in which today we are proceeding with our topic which we call it volumetric analysis, particularly in the part in which involving in the calculation based on the percentage purity and impurity of acid and alkali. In that, when we talk about alkali, we are talking about the soluble base. So for today here, we are much concentrating on the calculations based on the percentage purity and percentage impurity of acids and alkalis. Let us start with the calculation based on the percentage purity and impurity of acids. So let us start with the question which posed here, which tell us that we have 25 centimeter cube of solution which contain 5.2 decimeter cube of impure sulfuric acid reacted with 25 centimeter cube of 0.1 sodium hydroxide. So this is the requirement which is required for us when we are going to calculating about the percentage purity and the percentage impurity of the acids. So our question here requires us to calculate the percentage purity and impurity of acids. So we have data here, so we can utilize that data to perform or to computing our calculations. Now, data which we have here, we have percentage Data which we have here, we have concentration of impure sulfuric acid. So what we require here is to calculate the Fletcher degree to see how it is. So the first thing to know is what we have. We have here concentration of impure sulfuric acid, but we are required to calculate the percentage purity or percentage pure of the sulfuric acid. So to note here is that in order to obtain the percentage purity of acid or percentage purity of a substance or a sample or a given sample, we are supposed to take that the percentage of pure sample over the percentage of impure sample times 100%. We will obtain the percentage purity of a given sample of matter. So let us see. Let us just see here how it is. So you have data, but this data which you have here, we have concentration of impure we have here, which is 5.2 gram per decimeter cube. But also what we are required to find here, we are required to find the concentration of pure. We are required to find out the concentration of pure. Concentration of pure don't have here in order to get. So that one among the data which means is concentration of pure. But in order to get to the concentration of pure, we are supposed to pass through the balancing chemical equation. So we are supposed to balance the chemical equation. The balanced chemical equation here is sulfuric acid plus sodium hydroxide which is our base. When sulfuric acid reacts with sodium hydroxide here we are going to obtain sodium sulfate. We are going to obtain sodium sulfate plus water. Due to the fact that this is a neutralization reaction, this is aqua as symbols of state equations, but also here this is aqua. But only that we are supposed to balance chemical equation in order to get a certain data, such as mole ratio. So here we have two hydrogen, here we have a single sulfur, here we have single sulfur, we have 4 oxygen, also here we have 4 oxygen, but also here we have single sodium, here we have 2 sodium. So we are supposed to place 2 here. When we place 2 here, we have been obtained that we have 2 sodium and 2 sodium. So we are balancing the content of sodium. But here we have 4 hydrogen, 2 hydrogen from here and 4 hydrogen from 2 hydrogen here, which give us the total number of 4 hydrogens. After getting 4 hydrogens here, we are supposed to balance that equation. So we are supposed to place 2 here. When we place 2 here, we will balance that chemical equation. So after placing 2 here to balance that chemical equations, let us say here, this gives us that the number of acid is equal to 1, but the number of base is equal to 2. So this is a very important data which we require during the balance of that chemical equation. But molarity of base, which we have, but also we have molarity of base which is equal to 0.1, and our base is sodium hydroxide. But molarity of acid we don't have, but volume of acid we have. So volume of number of base here, but also here let us see molarity of base is equal to 0.1. Molarity of base is equal to 0.1. So let us see another key concept we require. Volume of acid is equal to 25, but also volume of base is equal to 5.00 centimeter cube. That's the issue which you have. This is very important. This is very important things in which you require during our calculation. So So what is required here? We are required here to find out the concentration of pure sample. Concentration of pure sample. How to get concentration of pure sample? Concentration of pure sample, we are supposed to follow the steps in order to get the concentration of pure sample. So here we are supposed to use the formula of mole ratio in order to get the molarity of acid in order to be able to proceed with the other calculations. So let us see how it is. So molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. Here we need to find out the molarity of acid. So molarity of acid, volume of acid, number of base is equal to molarity of base, volume of base, number of acid. When we look about this one, we are required to find out the molarity of acid. So divided by volume of acid, number of base, divided by volume of acid, number of base. So this is cancelled out. After that being cancelled out, we remain the molarity of acid is equal to molarity of base, volume of base, number of acid over volume of acid, number of base. In which that is the equations here, which is very important for us to utilize. So molarity of acid is equal to molarity of base. Here molarity of acid is equal to number of base. Here molarity of base we have 0.1. So we are supposed to place 0.1 times volume of base, which is equal to 25, times number of acid. Number of acid is how much? Number of acid is equal to 1 over volume of acid is equal to 25 times number of base is equal to 2. Number of base is equal to 2. So here we are supposed to know that here we have molarity of acid is equal. Here we have this is 25. We have 25. We have 0.1 times 25 times 1 over 25 times 2. This one and this one can be cancelled out. So it will remain with 0.1 over 2. This 0.1 over 2, this we can look at it like that one. 0.1 over 2 times 10 or times 10. So here we have 1 over how much? 1 over 20. So 1 over 20, how it become? 1 over 20, here if you divide like this one, divide by 20 times 0, 0. Times 0 times 0 again. 100 times 5. So 5 times 0, 0. 5 times 2 is equal to 10. So our molarity here, molarity of acid is equal to 0.05 m. This is the molarity of acid. So here we have been obtaining the molarity of acid. After obtaining the molarity of acid, in which that molarity of acid help us know the concentration of pure. So molarity of acid here is equal to 0.05. If molarity of acid here is 0.05, let us start from here. Recall that molarity is equal to concentration. Concentration is equal to concentration in gram per decimeter cube over molar mass. So let us see how it is. So here we need concentration. So we are supposed to make subject. How to do so? We can do like that one. So with the cross multiplication here, concentration in gram, concentration gram per decimeter cube is equal to the same as to get the molarity times molar mass. Go to molarity times molar mass. So how to do so? So concentration here is equal to molarity, which is equal to 0.05 mole per decimeter cube times 98, which is equal to molar mass of sulfuric acid, 98.00 gram per mole. So this mole and this mole cancel, because one is upstairs and one is down. So when we are doing the multiplication, that is cancelled out. So that should be cancelled out. So let us do something. 0.05 times 98 is 4.9. So it's equal to 4.9. So concentration here is equal to 4.9 gram per decimeter cube. So our new data here will be obtained. So the concentration of pure sample is 4.9 gram per decimeter cube. If the concentration of pure is 4.9, if the concentration of pure sample is 4.9, let us recall. So the concentration of pure sample here is 4.9. So let us see how it is. Recall that percentage purity, recall that percentage purity is equal to concentration of pure, is equal to concentration of pure sample, over concentration of impure sample, But this one must be times or multiplied by 100%. Why it multiplied by 100%? It multiplied by 100% because we are finding the percentage. We are finding the percentage. That's why we are supposed to multiply by 100% in order to obtain the percentage, the percentage purity. So let us see how it is. So percentage purity here is equal to concentration of pure, which is equal to 4.9 gram per decimeter cube over percentage of impure, which is equal to 5.2 gram per decimeter cube, is equal to gram per decimeter. But this one must be multiplied by 100%. It must be multiplied by 100%. This is equal to percentage purity. Is equal to percentage pure. Is equal to percentage purity. So here we have the task to make this division. So divide. So we are supposed to divide by 5.2. Here to divide by 7.2. So here, to become 9.4. Sorry. Here, so here it becomes is equal to 0.94 times 100%. Times 100%, which this is equal to 94%. So the percentage purity, of the acid is 94. That is section number 1. But section number 2, or part number 2 here, we are required to find out the percentage impurity of the sulfuric acid. So let us see here. Let us just across to see what amount of impurity which obtained within that is sulfuric acid, or what amount of impurity are in the sample of sulfuric acid. So let us see here. Let us see how it is. In simple way, we have different ways on how to calculate it, but the simple way on how to calculate that is to take percentage impurity is equal to 100% minus minus percentage purity. Minus percentage purity. That's a simple way on how to obtain the percentage impurity of samples of given sample. So here it become 100 percentage minus 94 percentage, which is purity altogether. So let us see here how it is. So when you take 100% minus 94, you will remain with 60%. So we remain with 60% of a given sample. So here the percentage impurity, therefore percentage impurity of sulfuric acid is equal to 60%. So this is the percentage impurity of sulfuric. That is the percentage impurity of sulfuric acid. So that is how to calculate the percentage purity and the percentage impurity of acids. Let us proceed with the volumetric analysis, particularly in the part which you call it calculation based on the percentage purity and percentage impurity of alkali. So we are dealing with the alkali now, is not acid now. So let us see the data which obtained from the experiment here from the book. So let me see the data which recorded from the experiment in order for myself to calculate the different things. Question number 1 here tells us calculate the average volume of the hydrochloric acid used in the reactions, but also write the balanced chemical equation of the reaction, but also calculate the number of moles of hydrochloric acid and those of sodium carbonate used in the chemical reaction, but also determine the percentage purity of a sample of carbonate, or given sample of carbonate. But let us see the data which obtained from the experiment. The data which obtained from the experiment, period we are removing, period because it's rough, but we have volume number 1, V1 is equal to 16.20 centimeter, but also we have V2, in which V2 is equal to 16.25 centimeter. But also we have here we have this is 0.20, but also here we have 16 V3 is equal to 16.10 centimeter cube. This is volume 3 titer value volume which obtained from the experiment. That experiment tells us something. So let's just to see what things used or utilized here. The things which utilized during the experiment is that 6.63 gram. This is the mass which dissolved. This dissolved in 250 centimeter cube. To make solution in which in that solution 0.5 hydrochloric acid, 0.5 molarity of hydrochloric acid were used during the experiment. After knowing that 25 centimeter cube of sodium hydroxide, not sodium carbonate, 0.5 hydrochloric acid, but 25 centimeter cube. So V use the volume of base is equal to 25 centimeter, 0.5.00 centimeter cube used it. But also 0.5 centimeter cube of that, but the volume of acid will be obtained from upstairs. But also the molarity of a base you don't have, but you are required to calculate that molarity of base molarity of acid, and so forth. So we are required to find out. But at the end, we are required to calculate or to determine the percentage purity of the carbonates. But question number 1 here, we are required to balance chemical equation to find the titer value. So we are supposed to find the titer value, and the titer value can help us to get the volume, the volume of acid. So the titer value here, mean titer is equal to V1 plus V2 plus V3 in centimeter cube over 3. We are finding out the average. So the portion of how to calculate the average volume of acid, the average volume of acid here, we obtain from this one. So here we have 16.20 plus 16.20 plus 16.1. So both these are centimeter cube, but both this one will require to divide by 3. First to make it just the calculation, which is equal to 16.2 plus 6 plus 16.2 plus 16 plus 16.1, which is equal to 48 over 3. 48 over 3 is equal to 16.1, is equal to 16.1. If it is 16.1, so volume of acid here is equal to 16.10 centimeter cube. So this is the average volume. So average volume is average volume of acid is equal to 16.10 centimeter cube. So this question has been wound up. After knowing that here, we are supposed to balance the chemical equation. After balancing the chemical equation, the data which obtained from the balanced chemical equation will help us to know the number of acid and to know the number of base. So let us see here how it is. So let us find balance the chemical equation in order to get the number. So the chemical equation here is hydrochloric acid react with sodium carbonate. Sodium carbonate, in which when acid reacts with base, we are expecting particular carbonate we are expecting to get the result, and the result which expected here is salty carbon dioxide in the water. So the salt here becomes sodium chloride, which is aqua, plus carbon dioxide gas, plus water, which water is a liquid in the aqueous state, but this is aqueous and this is aqueous. So this is a balance. This is our chemical equation. But this chemical equation is going to be balanced. Here we have 2 sodium, we have single sodium. So here we are supposed to place 2 here. When we place 2 here, this is double chlorine here. This is double chlorine here. So here we are supposed to place 2 here. When we place 2 here, our equation will be balanced. If our equation will be balanced here, here we are supposed to know that if our equation here has been balanced, we are supposed to know the number of acid and number of base. How we can know the ratio between acid and base? The ratio between acid and base, we are taking the reactant sides, not in the product side. In which in the reactant side is this region. Reactant side is this region. This region is where we are considering the number of ways. So the number of acid here is equal. The number of acid here is equal to 2, while the number of base here is equal to 1. The number of base is equal to 1. The number of acid is equal to 2. But this helps us to find out the molarity of acid and the molarity of base. How to know the concentration of pure sample of base? The concentration of pure sample base, we recall that molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. So molarity of acid, volume of acid, number of base is equal to molarity of base, volume of base, number of acid. Here our intention to find molarity of base. If our intention to find the molarity of base, so molarity of base, volume of base, number of acid is equal to molarity of acid, volume of acid, volume of base, number of base. So we're supposed to divide by volume of base, number of acid, divided by volume of base, number of acid. We cancel this one. We will remain the molarity of base is equal to molarity of acid, volume of acid, number of base over volume of base, number of acid. That's what we remain with it. After remaining with this one, this you can obtain, this you can utilize to find out the next procedure. So here we remain with the molarity of base. Molarity of base is equal to molarity of acid, volume of acid, number of base over volume of base, number of acid. After knowing that, let us remove this downstairs. So let us proceed with our calculation. So molarity of base here is equal to molarity of base is equal to 0.5 times volume of acid is how much? 16.10 times number of base how much? Number of base equal to 1 over volume of base is equal to how much? Volume of base is equal to 25 centimeter cube, 0 times number of acid is equal to 2. So let us see how it is. So molarity of base here is equal, let us see to see how it is. 0.5 times 16.1 over 15 is equal to 0.161. That is molarity. That's the molarity of base. This is molarity of base, or we call it mole per decimeter cube, or mole per decimeter cube. After obtaining, so this is the concentration of base. That's the molarity. That's the molarity of acid. So molarity of base here is equal to this one. Is equal to 0.161 mole. After knowing that, this molarity of base will help us to know the concentration or the mass concentration, which denoted mathematically as a gram per decimeter cube. So let us see how it is. We are just recalling. When we recall, we will turn back. But see, molarity is equal to concentration. Is equal to concentration, which that concentration is a gram per decimeter cube. Concentration which we are talking here is the gram per decimeter cube. After knowing that is the gram per decimeter cube, here we are supposed to divide by molar mass. How we can do so? Let us see. So molarity is equal to concentration in gram per decimeter cube over molar mass. Our intention here to find what? We need to find the concentration. If we need to find the concentration, here we are supposed to do something which is very important for us. So we're supposed to make subject. When we make subject here, we write up that concentration is equal to concentration in gram per decimeter cube is equal to molarity times molar mass. Molarity times molar mass. If it's molarity times molar mass, here we're supposed to know that the molar mass of sample which we need to find out its percentage purity. What are the molar mass of sodium carbonate? We are supposed to know that sodium carbonate is the same as taking as sodium carbonate sodium carbonate. Sodium carbonate. This is 23 times 2. This is plus 12. This is 16 times 3. If it's that, so here we are telling this is 46. Oh, okay. Let us do here. So this is sodium carbonate. This is sodium carbonate. Sodium carbonate. If sodium carbonate here is equal to the same as 23 times 2 plus 12 plus 16 times 3 brackets. In the product here, this is 46 plus 12 plus 48. But this also plus, this is equal to 80, this is equal to 58 plus 48. In which this is equal to 60, here is equal to 9, and 1 is equal to 10. So 10 gram per mole. So the molar mass of sodium carbonate is 1, and hydrated sodium carbonate is equal to 160 gram per mole. If it's gram per mole, let us use this. So molar mass here, molar mass is equal to 106 gram per mole. Let us utilize that value. So here, so 0.161 times 106, and 1 is 0.161 times 106. Here we get 7.066. You get this, which equal to concentration, which this is a gram per decimeter, per decimeter cube. After obtaining that 17.066 multiplied by that, so this is the concentration. This is the concentration of pure sample, This is concentration of pure sample. The concentration of pure sample is this one. So concentration of pure is equal to 17.066 gram per decimeter cube. This concentration of pure. Let us find how it's very simple to calculate to find out the concentration of impure. The concentration of impure is very simple. To convert this 250 centimeter cube, the centimeter cube, convert to 1 decimeter cube. We are calling that 1 decimeter cube is equal to 1,000 centimeter cube. What about the 250 centimeter cube? We are cross multiplication. We wind up with 1 decimeter cube times 250 centimeter cube over 1,000 centimeter cube. In which this and this one cancel out, so we'll end up with 250 divided by 1,000 become 0.25 decimeter cube. So this decimeter cube, take 6.63, which is a gram, in which is equal to mass over 0.25 decimeter cube, in which this will become, we'll take that one, take 6.63 divided by answer, we get 26.52 gram per decimeter cube. So this which obtained here, this is the concentration of impure. Concentration of impure, of impure which obtained the first time. So this one divided by this one to find out in terms. So this decimeter cube become 0.25 decimeter cube. It's 0.25 decimeter cube. Take this mass concentration sometimes equal to mass over volume. So when you take it when you take mass of volume, you can get the concentration. So let us proceed. So the concentration of impure and the concentration of impure is equal to 26.52. If it's 26.52, let us recall in our formula which can help us to find out the solution which we are intended for. So recall for that percentage purity is equal to concentration of pure, but what this is gram per decimeter cube, because we are talking about the mass concentration over concentration of impure over concentration of impure sample but both is gram per decimeter cube, but both these we are supposed to multiply by 100 percentage. How it become? So let us see the concentration of pure half, the concentration of impure half. So it's very simple for us to calculate. So let us see here how it is. So the concentration of pure is equal to how much? The concentration of pure sample is 17.06 gram per decimeter cube. Let us see right here, in order to be simple, 7.066 gram per decimeter cube, the concentration of pure over concentration of impure, which concentration of impure is 26.52 gram per decimeter cube. This is percentage purity of sodium carbonate, but both this multiplied by 100 percentage. So let us see how it is. So 17.066 divided by answer, it become here 0.6435. This times 100 percentage. Let us see how it is multiplied by 100 percentage. So it becomes 64.3514 percentage. So the percentage purity of sodium carbonate is equal to 64.3. So let us see how we can find out the percentage impurity of sodium carbonate. Let us see how it is. So the number which you've been given that. So percentage impurity is equal to 100 percentage minus percentage purity, or you can obtain percentage impurity. So how can you find it out? So let us see, 100 percentage minus 64.3514 percentage, which is the percentage purity. So let us see how we can obtain the percentage impurity. So let us see here that 100 minus 64.3514. So remaining 35.64 486, which approximately 236. So if the percentage percentage purity, percentage purity of sodium carbonate is 64, but the percentage impurity, percentage impurity of sodium carbonate is equal to 36%, while percentage purity of sodium carbonate is equal to 64%, of that sodium carbonate. So this is how to deal with the calculation based on the percentage purity and the percentage impurity of acid and base. Okay, up here let me invite my student or my learners in order to proceed with the short sessions of discussion and the practice of what we have been learned in our lesson. Okay, up to here. Welcome, my learners.
Question said 5.1 gram of impure sodium carbonate solution was dissolved in water to make 500 centimeter cube of solution. 20.00 centimeter cube of this solution was titrated against the 20.50 centimeter cube of 0.04 moles hydrochloric acid. Calculate the percentage purity and impurity of sodium carbonate. First, we have to know our data given. Yes, for our question, what is our data given? How many we have? Yes.
We have 5 data given.
Okay. The first one, let's put the first one. Yes.
Mass of impure sodium carbonate.
Mass of impure sodium carbonate. That is
5.1 gram.
The second one. Yes.
Volume of the sodium carbonate.
Volume of impure sodium carbonate, that is
500 centimeter cubic.
500 centimeter cubic. And the third one. Yes.
Volume of sodium carbonate.
Volume of sodium carbonate, that is volume of
Base.
volume of base. 20.00 centimeter cube. And the fourth one. Yes.
Volume of acid, which is 20.50 centimeter cube.
Volume of acid, that is 20.50 centimeter cube. And the last one. The last one. Yes.
Molarity of acid, which is 0.04 of hydrochloric acid.
Molarity of acid, it is 0.04 moles. Okay. From that data, which data we have missed? Yes.
Number of acid.
Number of acid. Number one.
Number of base.
Number of base.
Yeah.
So where we can get it? I think we can end.
Molarity of base.
And molarity of base. Okay, molarity of base. Where we can get number of acid and number of base. Yes.
We can get it through balance the chemical equation of between sodium carbonate, which reacts with hydrochloric acid.
Yes. Sodium carbonate react with
Hydrochloric acid.
hydrochloric acid.
What the product will be expected?
Yes.
We get sodium chloride.
Sodium chloride.
Sorry,
Yes.
with this carbon dioxide, with this carbonate or carbonate.
Ah, yes. Let us proceed. The product will be, yes,
Sodium chloride.
sodium chloride, and
Carbon dioxide gas.
carbon dioxide gas, and yes,
Water.
water. What will be the state symbol for this equation? For sodium carbonate will be, yes,
Aqueous.
aqueous. For hydrochloric, yes,
Aqueous,
aqueous. For sodium chloride,
Alkalis.
also aqueous. For carbon dioxide,
Yes.
yes. And for water,
Liquid.
liquid. So we have to balance the equation. Sodium, we have how many sodium in this side? Two sodium. And this side,
one.
so what we must do?
Must be adding 2 and sodium chloride.
Sodium chloride. So the sodium will be 2 in reactant side, and the sodium will be 2 in product side. Then carbon, have carbon, one carbon in this side.
One carbon.
So carbon is balanced. So hydrogen, oxygen,
Very oxygen.
and this side.
Very oxygen.
So oxygen is balanced.
Yeah.
For hydrogen,
In the reactant side we have 1 hydrogen.
100, and the product side.
We have 2 hydrogen.
So what we must do?
Must be added 2 in hydrochloric acid.
So we have 2 hydrogen in reactant side and 2 hydrogen.
In product side.
So hydrogen is balanced, and chlorine
Also balanced.
also balanced. So our question is already balanced. So what will be the mole ratio for this equation? First, what is the type of reaction? Yes.
Acid and base reaction.
So mole ratio will be, yes,
Our mole ratio will be 1:2.
1:2. In which one is
Number 1:2, what does it mean?
1:2 means number of acid and number of base.
in which one is number of
Acids.
acid. And the two is yes,
Number of base.
number of base. So we have already obtained,
Sorry, sir.
yes,
In number of acid we have 2. And number of base we have 1.
number of acid is
2. And number of base 1.
Number of phase 1, number of acid is 2. Okay. So we have already get our data. So we remain with molarity of base.
Okay, now we are going to find the molarity of base. Which formula will help us in order to find the molarity of base? Yes.
Molarity of acid
Molarity of acid
times volume of acid
times volume of acid
over molarity of base
over molarity of base
times volume of base
times volume of base
is equal
to
number of acid
number of acid
over number of base.
over number of base. So this is our formula that will help us in order to find the molarity of base. So what will follow in order to us to get the molarity of base? Yes,
Cross multiplication.
in order to make subject the molarity of base. So we will cross multiplication in order to make the subject the molarity of base. Now our formula will be molarity of base times volume of base times number of acid is equal to molarity of acid volume of acid times number of base. So what will continue in order to get in order to us to get the molarity of base? Yes.
Divide both sides volume of base
To divide both sides by volume of base
times number of acid
times number of acid. So here also will divide by volume of base and number of acid. So what is follow?
cross volume
So
of
we will cancel number volume of base and number of acid, volume of base and number of acid in order to remain with molarity of base. Okay. So our formula now says that molarity of base is equal to molarity of acid times volume of acid times number of base over volume of base times number of acid. Okay. Molarity of acid is equal to
0.04.
0.04 times volume of acid is equal to
20.50.
20.50 times number of base is equal to 1. Okay. Divided by volume of base is equal to
20.00.
20.00 times number of acids that is equal to 2. Okay. What is the expected answer? Yes.
0.02.
0.02. And what will be our SI unit? Yes.
Mole per decimeter.
It will be mole per decimeter cubic. So this now is the molarity of base. So
Is it capital letter per decimeter cube or mole per decimeter cube?
mole per decimeter cube.
When you write capital letter A, it indicates that it's mole per decimeter cube in collectively. So we are supposed to write mole per decimeter cube, not A per decimeter cube.
So it will be mole per decimeter cubic. So now our molarity of base will be 0.02. We're going by find the concentration of pure substance. In which formula will help us in order to get the pure substance? The formula will be yes. Molarity
Is equal to concentration
is equal to concentration
of molar mass.
over molar mass. So we need the concentration of pure substance. How will we get concentration? Yes,
We make subject concentration.
we need subject
Cross
concentration
multiplication.
by crossing multiplication. After that, we'll get concentration concentration is equal to polarity times molar mass. Okay, we are going on. Our molarity is equal to
0.02.
0.02 mole per decimeter cubic times molar mass. We will use molar mass of sodium carbonate. Molar mass of sodium carbonate is equal to
106 gram
and 6 gram per mole. Okay, what is our answer here? Yes,
2.12.
2.12, and our SI unit will be
gram per decimeter.
gram per decimeter cubic. So this is the concentration of pure substance. We are going on by finding the concentration of impure substance. Okay, now we are continuing by finding the concentration of impure substance. In which formula will help us in order to get the concentration of impure substance? Yes?
Concentration of impure substance
Yes.
is equal to mass per volume.
Okay, concentration is equal to mass over volume. Okay. Our mass is equal to
5.1 gram.
5.1 gram over. Our volume is equal to
500 centimeter cube.
500 centimeter cubic. But we must change it into decimeter cubic. In which formula will help us in order to change 5 gram centimeter cubic to decimeter cubic? Yes.
1 decimeter cubic,
1 decimeter cubic is equal to
1,000 centimeter cubic.
1,000 decimeter
Centimeter cubic.
1,000 centimeter cubic. Okay. If it that we place 500 here centimeter cubic in order to get it, how many decimeter cubic will it be? So what is continue?
Cross multiplication.
Cross multiplication, and the answer will be x times 100,000 centimeter cubic is equal to 1 decimeter cubic times 500 centimeter cubic. What is called?
Yes. Divide 1,000 centimeter cube both sides.
We will divide it by 1,000 centimeter cubic both sides. After that, what is called?
Crossing.
So we are cancelled 1,000 both sides. And here and here we remain by x is equal to, what will be our answer here? First we will cancel centimeter cubic and centimeter cubic. We remain with our 1 decimeter times 500 over 1,000. And easily when in order to get the answer, we will cancel 2 0 and here we will cancel 2 0 in order to get our answer easily. So now what is our answer? Yes?
0.5.
Our answer will be 0.5 decimeter cubic. So this is our volume in decimeter cubic. So our volume in decimeter cubic will be 0.5 decimeter cubic. Okay. Our volume will be equal to 0.5 decimeter cubic. Exactly is that what is our volume? What will be our answer here?
$10.22
10.22
gram per decimeter cube.
gram per decimeter cubic. So this is our concentration of impure substance. Now we're going by finding the percentage of pure substance and the percentage of impure substance, because our question says that we must calculate the percentage of pure substance, of impurity, and percentage of purity.
Okay, now we continue by we've already getting concentration of pure substance of sodium carbonate, and also we've already getting concentration of impure substance of sodium carbonate. Okay, we've already getting concentration of impure sample, and also we're already getting concentration of pure sample. So now we're going to find the percentage purity. By percentage purity is equal to
Concentration of pure sample.
concentration of
Pure sample. Over concentration of impure sample. Times 100.
Okay. Concentration of pure sample, how much?
2.12 gram per decimeter.
2.14 gram per decimeter. Concentration of impure sample is
10.2 gram per decimeter cubic.
10.2 gram per decimeter cubic times 100%. Okay, our answer will be
21%.
21. So this will be the percentage purity of sodium carbonate. Now we'll continue by finding the percentage impurity of sodium carbonate.
Okay, we are continuing to find the percentage impurity of sodium carbonate. Okay, which formula can use we can use in order to find the percentage impurity of sodium carbonate?
100%.
100%.
Minus percentage purity.
Percentage. Okay. How many number of percentage purity you get?
21.
21%.
Right. The answer
79%.
79%. So this is the answer on how to get the percentage impurity of sodium carbonate. That is the end of this question. We have to find the percentage of purity and percentage impurity of sodium carbonate.
Okay, this is the end of our lesson for today. So you are welcome